Hello, everyone. D. Alfred Ostrowski here. In this recording, I'm going to be giving you a Holo Solidity tutorial again. In this case, we're relying on Hardhat, personal blockchain, and the Hardhat console to do a really quick hello world. So this is great if you don't have any prior exposure to Solidity. It also might help if you have some blockchain experience already, and perhaps you haven't worked in the Hardhat environment. So this could serve as a great introduction to that as well. So let's get started. As usual, I'm using Amazon EC2. Why? It's quite simply the easiest way I've found to transfer solutions to you, and you can get it running exactly in the same fashion that I am right now. So I'm going to be taking all my commands off the GitHub page. That'll be posted along with the video as well. So let's get started. Okay, so I'm going to do a launch instance. I'm in the EC2. I'm only assuming you have an Amazon account and a PPK key generated and some access to client software. You can even use the Amazon console in some cases, but I run multiple terminals. So I use PuTTY. It's tried and true. It's been around forever and a day. So I'm going to bring in the Ubuntu instance. It gives me 2204. We're all in the same common playing field here. So that works really well. So I'm going to use a C5 instance. Be nice to use free tier, but it just doesn't run that well on some of the free tier instances. We got to pay a little bit more. I'm going to use a PPK key that I have generated already and get started. I'm going to bring in the terminals. I'm going to bring two terminals. One is to start my personal blockchain node, and the second, I'm going to run the command console. I'm running it all from EC2, so I'm going to have to take my brand new address and pull it in here. So there we go. Just had to refresh my screen. I don't have a password on the Ubuntu instances, so I just log in as Ubuntu. Bring in my second terminal again. This is going to support my console. And after I do this, I'm going to cut paste my commands to install everything and get everything up and running. Now, in the past, some of my earlier videos, I've been using an earlier version of Node. I've bumped up my version of Node to keep that relevant as of this recording. Some of the version 14, for example, I'm getting deprecation messages. So I try and revise, if at the very least, some of these other recordings on flash loans and forking to reflect that change, and any changes, I will try my best to update my GitHub appropriately. So here I have sudo app update. And I'm going to use curl to bring down the node and build the appropriate script. And I'm going to dig up the reference for this that led me to this technique and include that for your reference as well in the GitHub. I'm installing Node, and I just defaulted that install. Now I'm perhaps installing more libraries than I need to do, but I'm going to put in ethers and the chai test API and so forth. So this command is very useful down the road, a little more advanced. work with Hardhat and the Ethers library. It's giving me similar dynamic to Web3, so it's somewhat of a equivalent library to do the access between your applications, taking you directly to the blockchain. So here it defaults me for the starts of the system services, and I just default that appropriately. So that was Node, and now I'm going to install all of the Ethers library. Again, not going to step through all the individual libraries being installed here. Please reference GitHub, and you won't have to stop or restart this page to make sure that you got everything appropriately. You should be able to cut paste. And again, under 20 minutes, you should be up and running with Hardhat. And the version of Solidity that is supported through that, and running your first Solidity smart contract, or running a implementation of Hardhat. Okay. So I'm going to bring in a project directory. I'm just going to do a make dir test and cd to it. And then I'm going to do npx Hardhat. This will both download and install a Hardhat project. I'm going to default that, create a JavaScript project. Under the test directory, add a git ignore, and put in some of the default dependency libraries. They'll install real fast. Get another advantage. C5 runs a little bit quicker than the T2 resources. I don't leave it up and running. It can run up a substantial bill. At very least, stop it, if not terminate. If you stop, you're still being incurred charges here. Okay, so keep that in mind. Now, to be consistent, I'm going to go to the contracts directory. And I'm going to initiate a new file using the VI command editor, old try tested, but we're not doing a lot of fancy editing here. You might want to install, if you're doing more advanced work, obviously, an editor of your choice. I like VI for a lot of the quick and dirty stuff. Why? Because I'm using this as a sandbox, then VI is always there, and I know I can use it, and I don't have to worry about installation if I'm starting from a clean slate. I've used this in a number of other videos. What are we doing with this smart contract? Okay, you should be familiar with the syntax. If you have some familiar with programming in a C-based language, but just run through this in a few seconds, right? We're using Solidity 8.9 or higher, and I'm naming my contract hello, and I'm basically storing a string public data. I'm generating an event, and this will serve a purpose as a logging function. And I have a set and get operation, simply passing a string, assigning it, emitting the event, and having a get operation to retrieve that event. So in the context of the blockchain, I'm being charged money to do a set for any type of rate to the blockchain, and it's free to read the blockchain. That's it. Good to go. Let's start, and I don't have to manipulate my configuration file here. I'm just doing, even in the context of the cloud. Reason being is that I don't have an application touching this. That might get lost and misunderstand what localhost is. I'm doing everything from the command line, which, if you don't know me by now, I love, right? Because it allows me to break problems down and immediately look at the output and step through any difficult situation, or even build up assertion testing, which is imperative in blockchain development, right? So let's just start up the node itself with Hardhat. And I want to, before I do that, actually, I'm going to just back out. I want to go out of the main project directory just to be consistent, okay? And not any higher up than that, because it would try to reinstall Hardhat if I go outside of my project directory. So I started up Hardhat, up and running. It gives me 20 accounts as a pair compared to Ganache gives me 10 here. I have 20, 0 index, 0 to 19, and I have 10,000 ETH. So I get a lot more money to work with. It's not real money, so I'm not going to get too excited about it. But again, very powerful, especially in the context of forking mainnet. I can use these accounts to great advantage and not have to worry and beg these testnet faucets, which if you do a lot of testing can quite literally drive you crazy, right? So this really simplifies the whole process of learning blockchain development, as well as testing your smart contracts, and most importantly, getting that experience working on test networks and the main Ethereum network, right? So that's up and running. Now I can bring in the console and we're ready to go. I'm going to do npx Hardhat console dash network. Again, if I have a more specific solution, I'm going to run this on the test network. So again, make sure I CD the test, both on the same machine, obviously here, and I'll bring up the npx Hardhat, and this is giving me functional equivalent of the node with Ganache. If you saw my earlier video with Solidity that I just recently updated, right? So in here, it compiled two Solidity files. Why? Because I had a default file called lock.solidity. That's a demo program that they give you with the Hardhat environment. And I created the whole world. And interestingly, you notice we didn't install Solidity in this case as compared to Ganache. So Hardhat environment already installs an updated version of Solidity. You're good to go. And Hardhat is becoming very popular with blockchain development. Why? Because it gives you a lot of additional means of configuration and has a little bit more support towards forking and some of these more advanced developments. So for this reason, it's gained a lot of acceptance in the Ethereum based community, right? So here I've compiled two Solidity files. And typically I would use a deployment script, right? But as I demonstrated in similar nature with the Ganache environment, I can just deploy it straight from the command console. And I have a lot of fun doing it, right? So let's do it. It's always good to know a few different ways to step into your problem. So here I can do a few things here is at the console. I could pull in those accounts specifically, okay? And so let's do that. I'm going to use the ethers library, and get signers does that for me. So and I can see the interaction. So I know that I already have the confidence, right? I have the immediate response from Hardhat command console. And if I bring in signers, I can see the response in JSON format. And if it didn't work, you're going to know immediately. It's going to give you an error message, right? And what can I do with that? So immediately I can just look at the bounds and I have it at programming level, right? So I can start to build up my assertion testing in this fashion. I can test portions of code before I put it in a React application and do a lot of interesting things line by line and really get a comfort level. And I can pull in that balance, and that's the 10,000 with of Ethereum in way, right? So it's 18 zeros. I'm not going to count them, but this is the internal representation. And the reason for that is it uses a much lower unit, so it doesn't have to express fractionals, right? So that's the whole purpose of having the disparity in the unit. So again, if you don't have prior exposure, this is a great way to break down the problem a little bit and look at it line by line, look at my output, and have that immediate confirmation that something's working, as opposed to editing a file, putting in React, starting up React, so forth. Of course, you can do this in Remix. In my opinion, this takes us a little bit closer to the code. And Remix, like any environment, is very powerful. I use it, but I like both ways, right? I think it's a great way to approach your problem and step into it. So let's reference that contract. I've already compiled it. If it didn't compile appropriately, it would have given me an error on starting in the console. Here I can use get contract factory For those of you that already have prior exposure, this is in deploy.js already, right? So this is kind of taking the deployment script, running it, the lines that we need. And I can see on the left-hand side, again, that you have that confirmation and it's pulling reference to that contract. It would give me an error otherwise, and I have an address. I can use the get address method. In most cases, you might be able to hash it out. In this version, I believe I typically have to use a method to pull that out. But you probably hash that out if you wanted to. So a lot of interesting ways if you're already well-versed with JSON, right? You can hash in and pull out any type of information if you need it for advanced development techniques. So now let's do the deploy. I'm going to deploy my smart contract. And I can see in the back, I generated a transaction and I actually was charged an amount of money. Okay, and you may be wondering, well, what account? Typically take it from the first account, and you can check the balances on that. Here, I'll just check balances on the action of actually writing, and then, of course, with reading, it's for free. So let's pull that in. And I can look at it right now, right? And that'll give me the, so let's do assign to 0. That was the first one, so let's just call balance 2, right? Set as a constant, so I go balance 2. It gives me less than 10,000, so I actually use that first account. And that's the difference, right? So if I take that gas use, then I have the subtraction amount against my balance of ether. So I have less than 10,000 ethers at this point. Why? Because it costs money to deploy to the smart contract to my Ganache. I'm sorry, to my Hardhat personal blockchain. And here I can just set any type of string. And here I call it CD, and I'm using await. You always want to be in the habit of doing that. That way, you're always going to get an appropriate response. And here I have another response on the left-hand side. And I can grab that balance again. And we can compare those balances, right? And then I can do the appropriate get. Now, this gives you an appreciation of using await and the asynchronous activities, these actions that they launch an activity and it may proceed with the code. So you have some type of race conditions that exist. Await says wait for this to complete before I move ahead with the control. So if I assign something to it, then I'm going to always have a value that's returned. So that's why I use await. And here I return that value, and you saw that it read, and here's the difference, right? There's no gas used to do, so I see here, there's no gas used to read from whether it's testnet, personal blockchain, or the mainnet, right? It's free to read, it costs right to deploy, and it costs money to write to it. So let me grab the balance again. I just call it balance 4, and we can look at my balances. I could say balance 1, balance 2, balance 3, balance 4. So from the balance 1 to 2, that was the deployment, and they took an amount. The write, that took yet another amount. And lo and behold, the read was free. So I took the balance afterward. So we went from 0, we installed Hardhat. You put together your first smart contract, deployed it to your local blockchain. We read the appropriate accounts to our JavaScript console, Node.js, that is supported through Hardhat. And we deployed, wrote, and read from our personal blockchain, that single string. So this is a great way to test out your smart contracts. Of course, you can use Remix, just another way of doing it. And I think, again, this is a nice transition from some of your remix activities to actual testing or supporting. Again, you're going to be doing serious assertion testing. You're not going to manage them through remix because it's not programmable in the same fashion as you would just build collections of JavaScript assertion based activities that are going to run as a job or some type of script that you might run over and over. So this allows you to test that out and get a good comfort level with that. So I hope this helps. Enjoy it, try it out for yourself. Everything I've done is posted on GitHub. It'll be referenced with this video. And thanks for listening. Like and subscribe if you like it. And take care. Talk to you soon. A lot more content on the same theme here. So thanks again. Have a great day.